So now I want to change gears just a little bit and talk about some of the resources that have been put together through the SolCAP project. And so this is the SolCAP main web page. Again, if you go to the buttons, you see that for tomato there's some information on the germplasm that's being used in the project. There's a link for some of the phenotypic data, and then there's another link for the genotype data. You scroll down and there's links for tools. And those tools include some searchable data sets of intra and intervarietal Sniffs. And I'm going to focus on those for just a little bit. So if we go and look at the SNP site for tomato, Robin Buell and her group did a comprehensive analysis of SNPs comparing TA496 and Heinz 1706. Okay, so these would represent SNPs in processing backgrounds. If we scroll down on this page, you can search by chromosome if you wish. So I'm focusing on chromosome 11 here because this is a chromosome that has a couple of genes that we're interested in for bacterial spot resistance. You could search all chromosomes at the same time if you wished. You can also select the minimum EST coverage, and this is an important point here, and it's relevant to the question of quality of data. So remember I mentioned that EST data comes from single-pass sequencing. That means that the data are someplace in the range of 99% accurate. It turns out that the real SNP frequency is at less than 1% in cultivated tomatoes, and that means that you need some redundancy of data in order to avoid identifying electronic SNPs that turn out to be sequence error. And so my recommendation is that you set this minimum EST coverage between 3 and 4. Okay? And what we've found is that when you set it in that range, that the validation rate, in other words, the ability to turn that SNP into a marker, is up in the 85% range. Okay? If you leave it at 2, the validation rate drops significantly. Okay. Okay, so the other thing that I want to point out is that on this website you can download the assemblies that Robin's group put together for TA496. Okay, so there's been some bioinformatic condensing of the data that's gone in here, and this represents essentially a unigene set for single variety TA496. Okay, so once you run the search, this is what comes out, and what I want to point out is that it's provided to you in a tabular format, but then there are links either to the SolCAP assembly here or back to the GenBank accession from the Heinz 1706. And so this would represent, the GenBank accession for Heinz 1706 would represent a back sequence, and so it's going to be very large, whereas the SolCAP assembly is going to represent a much smaller gene-based sequence. Okay, and so that's retrievable by simply clicking on the links. Okay, so there are some other resources that are available on this website that I would encourage you to look at. So one of the things that's been posted recently is a complete set of SNPs that are going to be used to develop an Illumina genotyping tool. And so that contains over 8,700 SNPs, and in our validation studies we found that about 96% of those turn out to be useful markers. Okay, and so the SNPs themselves, their annotation and sequence context are available now on the website. Okay, so finally in the last 5 to 10 minutes that I have available, what I want to do is talk about how you can use these databases to create customized sets of data for your own use.